It's normal for planets to be a bit tilted on the side. The Earth is tilted at a 23-degree angle. That's why we have seasons. It's summer when the part of the world where you are leans closer to the sun. It works the opposite way too. It's winter when you lean away from it. But Uranus is tilted more than normal. It lies as a 98-degree angle, which has a huge effect on its seasons. Each season on Uranus takes 21 years to play out. Something to think about the next time we complain that winter lasts forever. Now, here on Earth, we measure distances in minutes and hours, maybe even days. It takes 10 minutes to walk to your best friend's house, or 15 minutes to drive to your favorite cafe. But in space, it's different. It's vast, which means we measure how long it takes to get to a certain point in years, or in most cases, light years. So, if you want to walk to the moon one day, that would take you 9 years to span the 239,000 miles. Perhaps you'd like to take a ride to the nearby star, Proxima Centauri. Maybe if you kept the pedal to the metal at a constant speed of 70 miles per hour, you'd get there in about 356 billion hours, or around 40.5 million years. Trust me, after the first 20 million years, you'd be second-guessing yourself as to why go there in the first place. Now, Mars contains the biggest valley, Valles Marineris, we've discovered so far. It's a pretty impressive system of canyons, 2,500 miles long. That's 5 times longer than the Grand Canyon. Researchers first spotted it back in the 1970s. A bank of volcanoes located on the other side of the canyon ridge probably helped form this valley. We haven't discovered a planet completely made of diamonds yet, but on some planets, it actually rains diamonds. On Jupiter and Saturn, gas giants of our solar system, lightning storms turn abundant methane into soot, which we also know as carbon. The soot falls and transforms into graphite. Further graphite transforms into diamonds with a diameter of about 0.4 inches. Now, before you start figuring out how to book a diamond collecting field trip, know that these diamonds don't last. After they enter the planet's core, they melt. Ever notice how when you're stargazing 2 nights in a row in the same time, let's say 9 p.m., the stars stay in the same place, but the moon doesn't? Well, there are 2 reasons for that. First, it depends on what time you go stargazing. For instance, if you go outside at 8 p.m. and tomorrow you look for it at 11 p.m., you'll see the moon in 2 pretty different places. In this case, even the stars take different places in the sky since our planet is spinning. As you know, it takes 24 hours for it to make one full circle. That means, from our point of view, it seems like both the sky and everything up there is just moving around us one time per 24 hours. In the same way, the sun changes its position, rising and setting every day. So, if you went outside 2 nights in a row at the same hour, in most cases, you'll have to wait for an extra half hour or more until the moon gets back to the same position as the night before. The stars are pretty much standing still. It seems like they're moving, but that's because the Earth is spinning. But the moon is actually moving around our planet and goes through different phases. For example, a new moon is when it's completely dark in the sky. A full moon is when its day side is facing the Earth. It takes approximately a month for it to finish one circle around the Earth. Maybe you'd be luckier on a diamond collecting expedition on this next planet, 40 million light-years away from Earth. Scientists used to call it a super-Earth. Now, a super-Earth is generally a planet way bigger than ours. This planet, for example, is double the Earth's size. It's so close to its star that it makes a full circle around it in less than 18 hours, which means a year there is pretty short. Since it's so close to its star, its temperature goes up a whopping 4,900 degrees Fahrenheit. Because of the heat, in combination with the planet's density, scientists have the theory that its core is made of carbon in the form of graphite and diamonds. Over 10 years ago, astronomers discovered a huge water vapor cloud. It was 12 billion light-years from our home planet. That cloud is the biggest source of water we know of. It's also the oldest, dating back to when the universe was only 1.6 billion years old. Now it's 13.8 billion years old. Man, if only I had started a savings account 12 billion years ago. With compound interest, I'd have me quite a pile of cash by now, but I wasn't around then. Anyway, this cloud is so large it holds 140 trillion times the amount of water in all the oceans on our planet. This cloud kind of feeds a black hole. It may also contain enough gases, such as carbon monoxide, to encourage the black hole to grow 6 times bigger than it is at the moment. The average temperature of our planet is about 57 degrees Fahrenheit, and the highest temperature ever measured was 134 degrees. Sound too hot? Well, on Venus, it can go up to 900 degrees, which makes it the hottest planet in our solar system. It's not hot enough to melt steel, though. It would need to be higher by 2,500 degrees to get there. But it's hot enough to melt lead, and it's way too hot to sustain life, at least not in any form that we know. Venus is not even the closest to the Sun, it's Mercury, but it has a super thick atmosphere that traps greenhouse gases. It's like you covering yourself with a pretty thick blanket in the middle of the summer. Now, we're used to seeing volcanoes spewing hot molten lava. After all, that's what they mostly do on Earth. But in space, volcanoes tend to spew methane, water, or ammonia. And these materials freeze as they erupt and eventually transform into frozen vapor and something called volcanic snow. I'm talking about cryovolcanoes here. You can find them on Jupiter's moons Io and Europa, Saturn's moon Titan, and Pluto. These volcanoes are especially active on Io, which has hundreds of vents. NASA vehicles have even captured some of these erupting in real time. Plumes of frozen vapor coming out of them extended for about 250 miles. Hey, by the way, they just discovered another moon around Jupiter that might actually be good for farming someday. It's named EIEIO. Now, what exactly happens to the light after it disappears inside of a black hole? Well, photon is a particle of light. The event horizon is the boundary of a black hole. When something, say a photon, crosses the line and enters those boundaries, it can't escape anymore. But it doesn't mean a black hole destroyed it. It pulls the photon in rapidly towards its center, where an enormous mass is packed into an infinitely small space. But we're not sure what happens to photons in such extreme conditions. It's still one of the biggest mysteries. Does a black hole destroy the light or not? Saturn has 82 moons we know about, 53 confirmed and 29 more that are still on the waiting list to be confirmed as actual moons before they get their official names. And one of the coolest moons might be a 914-mile-wide hunk of rock called Iapetus. It's dark on one side and bright on the other. Its lighter half is 20 times more reflective than the other one. As it turned out, the bright side is ice. The dark side is a bit more complicated. One theory says it's dark because of particles coming from another moon, the one named Phoebe. Another theory says it could be because of heat. Since the moon is rotating really slowly, its dark material is absorbing heat, which makes it even darker. Now, how big do you think a black hole can become? In theory, we can't find an upper limit to its mass, but astronomers believe the ultramassive black holes, or UMBHs, located in the cores of certain galaxies are mostly up to 10 billion solar masses big. Recently, they even discovered these UMBHs physically can't grow much more than this, because, in that case, they would start to disrupt the accretion disks that feed them. That way, they would kind of stuff the source of new material. Most people picture the universe as somewhere between aquamarine and pale turquoise. Even some researchers thought that was the case. They managed to determine the cosmic color by combining light from more than 200,000 galaxies within 2 billion light-years of our planet. But the real color is actually closer to beige. Researchers got it all wrong because there was a bug in the software. No, really? It converted the cosmic spectrum into the color our eyes would see if we were exposed to it. The team defined this color as a cosmic latte. Ooh, make that a double-shot low-fat large to go, please.
"1.5 feet with the Earth's gravity. Verification complete. Now the simulation room will recreate Mercury."
It's so hot in here.
Yes, it's like standing next to a volcano. Your jump is 4 feet high. Now switch to Venus.
Wow, this place looks scary.
On the real Venus, everything is toxic.
I feel no difference.
Yes, the gravity here is almost the same as on Earth. Switch to the moon. Gravity on the moon is 10 times lighter than Earth's, 9 feet. The next one is Mars.
Huh? It's pretty comfortable here.
The gravity here is the same as on Mercury. 4 feet. Now, prepare for the struggle.
Huh? What do you...
There is no solid surface on Jupiter. Although Jupiter is a great deal larger in size, its surface gravity is just 2.4 times that of the surface gravity of Earth.
It's hard to even stand here.
Only half a foot. Got it. Switch to Saturn. There is no solid surface here either, but Saturn's gravity is almost the same as Earth's. Now Uranus.
It's so cold.
It's 5 times warmer here than on the real Uranus.
Seriously? My legs are...
1.7 feet. Gravity is slightly weaker than Earth's. That's Neptune for you. Your jumps are 1.3 feet high. Gravity is slightly stronger than Earth's.
Get me out of here!
Turn off the simulation.
We all remember seeing the Apollo lunar rover on the moon built for space missions in the 70s. Besides transporting astronauts for certain explorations, they were used for taking pictures and collecting soil samples for scientists to study. The vehicle was designed by Boeing, the company famous for building airplanes, and cost around $38 million to build. The kind of loose change you'd find today on Elon Musk's couch. In the far future, technologies will be so advanced that a regular car for the moon will behave like a regular SUV we have today. It'll have a sleek look and might be produced by some famous car manufacturers available. Back then, the lunar rover used a T-shaped throttle to move the car left, right, backward, and forward. The futuristic one can be voice-controlled and require minimal human control. And we can't leave out the Earth roof. Hey, you really don't need a moon roof on the moon. Anyway, the moon's driving conditions are not that extreme compared to Mars or other planets. It's hard to believe that the first landing craft to enter Mars was Viking 1, launched on August 20, 1975. It arrived at Mars on June 19, 1976. But decades later, Curiosity, which had 6 legs and 6 wheels attached, took the stage as the cute robot explorer. It was designed for the rough terrain, so in the distant future, a human-operated vehicle can have a similar design for people who want to cruise by the Mars sunset. For any human-designed car to work on planets other than the Earth, they have to be electric or anything else that can produce an unlimited supply of energy. Gas-powered vehicles won't work in the vacuum of space, and certainly not on any planet other than our own. It can be powered by the strong sun and convert the energy to run the vehicle. The interior has to accommodate the extreme conditions on the planet, since the atmosphere is very thin and unbreathable. It has to be very warm, since Mars can reach sub-zero temperatures. The matter of gravity isn't that extreme, but frequent dust storms are the problem. The vehicle will also have wheels attached to legs to maneuver around properly, since the terrain is difficult to get around in. Now, my 2 cents here? Well, I think an all-leather interior with 6-way seats front and back will be nice. Adding a 12-speaker sound system with RU Sirius FM radio is a must. Did I mention the Earth roof? Yeah, I did. And don't forget the 60/40 fold-down rear seats so you'll have plenty of room to haul your camping gear on your weekend escapes. Meanwhile, it's still possible to have a panoramic glass view of the interior in a project like a tour bus on Mars. There are plenty of locations to discover, like the tallest mountain in our solar system and the snowy Carbon Peaks. The Red Planet can also have an express train ride that can take you from one place to another. It'll be one of those luxurious cabins that will take you from one landmark to another since Mars becomes colonized and established. The train will also be electric-powered or powered by another power source. Mars is a place where it's possible to have all kinds of vehicles, since the conditions aren't that different from Earth's. Just don't go outside without a helmet. If we designed a vehicle for Mercury, then get ready for bright light from the sun, in which case we would need to add industrial visors and blackout strips around the glass so that the sun won't get to us. At least we won't have to worry about the heat, since Mercury isn't the hottest planet in our solar system. Well, the temperatures can reach a soaring 800 degrees on a warm sunny day and drop down to minus 300 degrees at night. The vehicle will have to have multiple layers and coatings to withstand the conditions. and it will most likely have spider legs to move since rubber wheels will melt instantly. And to save itself from damage, it'll need to dig underground to hide from the sun and atmosphere, just like a crab or those spiders that create hatch floors. Driving a vehicle on Pluto will be very challenging, considering that it's the furthest planet from the Sun. Now, Pluto is technically not a planet anymore, but it's still a large enough mass to explore. Temperatures there can reach below 400 degrees. A mere jacket won't cut it. The vehicle will need super insulation to keep the operator warm and fuzzy. Methane ice surrounds the land and covers the mountains. Gravity is also an issue since it's very weak, which will make you float in the air. Now, designing a vehicle for Pluto will be tricky. The key for it to move and not freeze will be how the legs move. It'll also have legs like the one on Mercury, but will have a lot of heat generated to keep warm. The weight is enough to keep this vehicle in place. However, that can't be said for Neptune, the windiest planet in our solar system. It's impossible to breathe in the atmosphere, and the atmospheric pressure will crush you. Designing a vehicle is challenging, considering the many external factors, and will have to be pressurized to counter the external atmosphere. It will also need a special coating to counter the harsh temperatures. And because Neptune is extremely windy, it would need some sort of anchor to keep it in place, something like a large drill that shoots from the belly of the car and digs underground. It will also have spider legs to move around, but they'll behave in a similar motion to how a camel walks. That way, it can maintain its center of gravity. Now, Venus is the hottest planet in our solar system, with temperatures reaching 1,000 degrees. The pressure will crush your vehicle like a can, so it needs proper internal pressure to balance it out. This car will require all the upgrades for countering the heat. It will need proper coating, no glass, and even a special color to reflect the heat. Nothing can actually stay on the ground for too long, so spider legs won't really work. It'll need to hover slightly above the ground and float around. Now, Saturn is the second largest planet in our solar system and has a very windy upper atmosphere and very strong gravity. The rings around it are made up of ice materials that can range from the size of a pebble to the size of a school bus. The pressure is so strong that you'd be crushed the second you reach its atmosphere. Designing a vehicle would be very challenging and weird. It'll need the best technology for withstanding the crushing pressures and harsh temperatures. The vehicle will have to be large and composed of many internal layers. Since the upper atmosphere is windy, the vehicle will have to remain on the ground for as long as possible. Scientists don't know much of what the surface looks like, so the vehicle will have to be prepared to move on solid surfaces, liquid, and anything else in between. Now, I think it's called slop. It'll need mechanical arms to maneuver through the possible rugged terrain and multiple legs like a centipede. Those arms can pick up things and move them out of the way if it faces some obstacles. The long body can also detach itself and break into smaller pods for a quick escape. From what, we don't yet know. No human can step foot outside even if they wear protective gear. Robots will have to be deployed to test how human bodies can withstand the conditions. Jupiter has harsher conditions than Saturn, with the red spot being the most dangerous area on the planet. It's an extremely large area that has hurricane-like storms that have been going on for years. The vehicle will resemble that of Saturn, but extra heavy-duty. Scientists also don't know what's happening on the surface except for the crushing atmospheric pressure. The vehicle won't be able to move on the surface if it were to pass through the red spot, so it'll have to dig underground and move underneath. For that, it'll require a huge drill and many self-automated drones and vehicles that can be deployed from the main vehicle to help with digging and surveying. Once underground, it'll have legs that will help it crawl and a giant drill nose to dig further. Many of the body parts can also break off into smaller pods to get through certain terrains, but can be easily reattached. The craziest place where we can launch a vehicle is the Sun. There's no way to imagine it except being self-automated. Any human on board won't make it halfway in the journey. The launch will have to be from Mercury in a protective facility sheltered from the harsh temperatures. The vehicle will have to be made out of the best resources to withstand the extreme heat and gases, and won't last more than a couple of minutes once nearby. It'll most likely resemble a satellite and float around to take some footage for us to study. It'll probably cost trillions of dollars, but the results will be worth it. won't they?